Black holes are some of the most mysterious and mind-bending objects in the universe. They defy our common sense, challenge our theories, and push the boundaries of what we know about space and time. Imagine an object so dense, so powerful, that nothing, not even light itself, can escape its grasp. That's a black hole. At its core, a black hole is a region in space where gravity has become overwhelmingly strong. This happens when an immense amount of mass is packed into an incredibly small space. To understand just how extreme this is, picture the mass of a star many times larger than our Sun being compressed into a sphere only a few kilometers wide. The result is a kind of cosmic trap, a gravitational well so deep that anything crossing a particular boundary, the event horizon, has no hope of getting out again. But how do black holes actually form? Most begin their lives as massive stars. These stars live for millions of years, burning through their nuclear fuel in spectacular fashion. When the fuel finally runs out, the balance between gravity pulling inward and pressure pushing outward tips. For stars several times more massive than our Sun, this imbalance triggers a catastrophic collapse. The star implodes, its outer layers blasted into space in a supernova explosion. What's left behind, if it's massive enough, collapses down to a single, unimaginable point: a black hole. At the edge of every black hole lies the event horizon. This is the boundary that marks the point of no return. Anything that crosses this invisible line, be it matter, light, or even information, is lost to the black hole forever. To an outside observer, time seems to freeze as something approaches the event horizon. But for anything actually falling in, the journey continues, though the experience is far from normal. There's a real effect known as spaghettification. Get too close to a black hole, and the force of gravity is so much stronger at your feet than at your head, your body would be stretched out long and thin, like a strand of spaghetti. This dramatic stretching is just one of the many strange and terrifying consequences of black holes' extreme gravity. So what happens inside a black hole? The truth is, no one knows for sure. Inside the event horizon, we reach a point called the singularity, a region where density becomes infinite, and the laws of physics as we know them break down completely. All of our current scientific theories, from general relativity to quantum mechanics, fail to explain what actually goes on there. That's why black holes remain one of the biggest mysteries in modern science. For a long time, scientists thought nothing could ever come out of a black hole. But then, in the 1970s, Stephen Hawking made a remarkable discovery. Black holes aren't completely black. Thanks to the strange effects of quantum mechanics, they can emit tiny particles of energy, a phenomenon known as Hawking radiation. Over unimaginable spans of time, this could cause black holes to slowly lose mass and eventually vanish. However, for the black holes we've observed, this process would take far longer than the current age of the universe. Black holes might seem like the stuff of science fiction, but they're an established reality. We've captured images of their shadows, traced the gravitational waves from their collisions, and mapped their influence across our galaxy and beyond. More than just cosmic oddities, black holes might hold the key to answering some of the biggest questions about the universe, questions about how gravity works, what happened at the beginning of time, and what lies beyond the edge of the observable cosmos. In the end, black holes show us that the universe is stranger and far more fascinating than we could ever have imagined. They remind us that even in the darkest corners of space, there's still so much more to discover.